A highway curve has a radius of curvature of 100 meters is banked at an angle of 15 degrees, as shown above. Determine the vehicle speed for which this curve is inappropriate if there is no friction. No friction. It is not realistic, but this is the theoretical problem. Okay, no friction between the roll and tires of the vehicle. Sufficient enough to keep the car from sliding outward, and maintaining its turning on the road. On the dry day, when the friction is present, okay, determine the vehicle. We need to do question A first because the lower statement here on the right day is due for other question B and C, not A.
Yes.
To find the speed, firstly we need to determine the forces acting on the car. There are three forces. Wait, only two because friction is doesn't exist, no friction. So the first force is the weight. This is the car. Free body diagram. Hey, that is so thin. Okay, the weight. The normal force perpendicular to the surface. This is the normal force. Let me draw the surface here. Okay, this is the roll. The normal force is perpendicular to the roll, okay, and it makes an angle of 15 degree compared to the vertical 15 degree compared to the vertical direction, because that angle here is equal to the angle, the banking angle 15 degree here. And the vertical component of this normal force, this is the vertical component, Ny. Ny must be equal to the weight. Okay. And yes, the Nx, the other component Nx here is the centrifugal force. You can draw a diagram like this in the real test. Even though, or if you don't, it is not a must, not a requirement to draw a diagram. You can do it outside somewhere else. Question B. On a dry day, when friction is present, an automobile successfully negotiates a curve at a speed of 25. Okay. The friction is in this direction. F. So that the normal force here must be actually greater than the weight, not lower. So the most important thing is to determine direction of friction. That's just weird. Difficult to draw the normal force. Okay, the normal force. Because now the vertical component, the normal force, subtract the vertical component of the friction equal to the weight. So the normal force is greater than the weight. Okay, and similarly, the horizontal component N added, not subtracted, with the horizontal component of friction is equal to the centrifugal force mv squared over r. Okay.
Yes.
So we need to change the sign here to the plus sign, and it is minimum. It cannot be zero, it must be greater than zero because this is the sum of two forces. The speed, are we given the speed? Okay, here the speed 25, it must be equal to the speed provided here, equal to mv squared over r, and therefore the minimum coefficient here, we need to calculate the normal force first because we do not know it yet. Okay. Yes. The normal force is calculated from the first equation here. Ny minus the friction component of vertical, meaning mu times the normal force times the vertical component is cosine of 15 degrees equal to the weight. And y here, okay. The coefficient multiplied with n only is the friction. Mu times n is the friction. And then the vertical component of that friction, we need to multiply with cosine of 15 degrees. Wait, sorry, sine, not cosine. Sine here of 15 degrees. Vertical component of its normal force is the normal force multiplied with cosine of 15. Cosine of 15 degrees. Okay. Equal to the weight. So we have the two equations, 1 and 2. Okay, do it again, the solution. Need to find mu. This can be written as mg. We can add the two equations side by side, okay? Meaning sine n times sine 15. No. Anyway, we need to find n and then plug into the first equation. Anyway, so n here is equal to mg divided by cosine 15 minus mu times sine 15, and then replacing to the first equation again. Mg times sine 15 degree added with mu times cosine 15 divided by cosine 15 minus mu times sine 15 equal to mv squared over r. Oh, I think I forgot to divide r last time. I know that the wrong thing where the wrong thing are now. Okay. Simplify m. Okay. Simplify m and then divide g. We have the following equation. G times sine, or we can divide g on this side, huh? V squared over gr, and then multiply with the bottom on this side, huh? Cosine of 15 minus mu times sine 15 equal to sine 15 minus mu times cosine 15. Okay?
Yes.
Oops. Be more careful when choosing the phrase. Yeah. Making mu common factor, moving 1 to the right, v squared over gr times sine 15 and minus cosine 15. And then mu is a common factor, right?
Yes.
This negative side becomes positive side here.
Yes.
And equal to v squared over gr times cosine 15. Subtract sine 15. Okay. Make it a little bit lower. There. Okay, now mu can be calculated. Mu is v squared over gr cosine 15 minus sine 15 divided by v squared over gr sine 15 minus cosine 15. Wait, put a plus sign. So there's a plus sign here. Mu common factor, moving that, yeah, plus sign here. V squared over gr times cosine 15 and then subtract sine of 15. Okay, subtract sine here. Add sine here. Okay. Times cosine 15 minus sine 15. Another bracket. And then divide that answer, multiply with sine 15 and then add it with cosine 15. 0.0 0.316, approximately 0.32.
Yes.
Now it is the answer. So if you see a question like this, you can skip it. From this equation, mg sine 15, etc., you can put all the value excluding the m, because you simplify m on both side equation, huh? Put this equation in a calculator, and then it can solve for you the value of the coefficient mu, which is a x in a the equation when you put into the calculator. And let me check if you are allowed to use a like graphing calculator that can solve equation. I think you are allowed. Don't bring these with a calculator, acceptable calculator here. Okay, acceptable calculator. So for many calculator, you can use it, the calculator, to find the solution of that equation. Okay, for physics 1, 4 function scientific graphing calculator allow, they all allow. Okay, let me change the sharing string, and I will use another calculator.
Yes.
I will make one sign like this. This equation will be equivalent to sine 15 degrees added with x cosine 15 degrees over cosine 15 degree minus x sine 15 degree subtract 25 square v square, huh, over g 9.8, and r is 100 equals 0. Okay. Yes. One side of the equation, which is given 0 here. Do you have the interface like this, the string like this?
No, it's all a bit different.
2 boxes, right?
Yes, 2 boxes.
Yeah. So one box you can enter this one, and the other box is this one without the negative sign. Okay.
Yes.
Without the negative sign. I sent you a link about to solving this equation like that into your one equation here into this box and the other into the other box with no negative sign. Okay.
Yes.
For my calculator, I enter the above equation. Sine 15. Don't forget to close the bracket, and then add it with the x, the variable, the mu we need to find, huh? Times cosine 15 bracket. Oops, 15 bracket. Actually, I need another bracket in front of that, so I miss a bracket in the front, and I need to type it in again. So annoying. Calculator. Add it with x times cosine 15 bracket divide bracket cosine 15 bracket minus x times sine 15 bracket twice, huh? One is for the angle and the other for the denominator. Okay, and then subtract 25 square divided by 9.8 multiplied with 100. Okay, this is the equation. Now I need to guess a solution. I can guess like 0.1 or 0.2, which is the common values, the popular value for the coefficient of friction. Okay, and must do that is a requirement for the calculator. Guess a solution. Okay.
Yes.
0.2, 0.1 or something, and then alpha, and so here is the solution 0.358